Hello, guys. Welcome back to part two. All right. You guys can hear me okay? Yeah, should be fine. You should be able to hear me. All right. So we just need the groups that are presenting. No, right? Welcome, welcome. All right. So if we check on, let's see what we have here. 3D modeling. All right, so we are now having topic 5 and 6 present. Wow, we only have one more reveal, and then that's it. We would have revealed all of the presentation topics. So topic 5 and 6. So do we have our members here? Miss Spence? No, Miss Spence not here. I don't see Miss Spence. Who we have here from topic 5? All right, cool. Joshua, I see you. Right. Good. And from topic 6, I see Miss Sorto. So I want you guys to just round up your group members, right? We want to get an early start this time because last time we did go a little overboard. So we want to get going, and we also need the presentations to be timely, right? So those two things need to happen. All right. All right. I see more people coming in. Let me get my notebook ready here. We are almost at the end of, well, today we'll be at the end of revealing all the topics, all right? So by now, if there's anybody who is not in a group, now is your last chance to be in a group. So I suppose everybody here is already in a group. Anybody here that's not in a group? I see no hands, so that means we are all in groups. All right. All right. So topic 3, 4, so topic 5 and 6. And 6. Topic 5 is going to be, how can we incorporate AI in the practice of architecture? All right, you guys ready for me? Topic 5?
Yes, sir.
All right. And my audience, is my audience ready? So you guys representing the other groups that are supposed to be asking questions in order to earn your grades. All right, so topic 5, you can go ahead and share screen anytime you're ready.
Good afternoon, sir. I send more requests to share screen.
Oh, I don't. All right, because I'm sharing. My bad. Okay. So I need to stop my share. There we go. All right, so anytime you're ready. So whenever we do the last presentation is when I will post the grades. Because I mark them during while you guys are presenting, but I'm just going to give the grades all one time. Uh, All right, so same thing as usual. Um, when you present, we'll take the two presentations and then we take all the questions at the end. I will give a feedback and then we take the questions. So, all right, good to go.
All right, so good afternoon, everyone. Um, we're group 5, and we were tasked with finding out how is AI using architecture and what exactly is AI. AI is short for artificial intelligence. And my name is Akira Williams. My group, we have Javel Hay, Mikesha Lawrence, Tatiana Boyce Redman, Joshua Watson, and Shamari Ryan. So now let's go ahead and start. Because I know this is a very interesting topic. But
Mhm.
first, how many of you guys right here use ChatGPT? Just raise your hand.
Me, sir, me.
Okay, okay. So that means that most of us here, we're familiar with AI. So everybody should be interested. All right, let's go ahead and start now.
So, as you all know, AI stands for artificial intelligence. And I guess in what I'm going to do now is basically give you guys a summary in what this presentation is going to be about. So, AI, artificial intelligence, allows computers to think and learn like humans. It performs tasks such as understanding speech, recognizing images, answering questions, and making decisions. AI learns by finding patterns in data, similar to how people learn from experiences. Common examples include virtual assistants, chatbots, automatic translators, and apps that generate text or images from prompts. Which, if you use AI, you basically do all of what was stated above. And a fun fact of this is that in the year of 2024, $252 billion was invested in the advancement of AI.
Just a little history of artificial intelligence, also known as AI. In 1921, the term robot, the word was first used by Karel Capek in a play. This play describes machines that could work like humans. In 1950, Alan Turing's idea created the Turing test to see if a machine could think like a human. This became one of the first big AI ideas. In 1956 was the birth of AI. by John McCarthy he used the term artificial intelligence for the first time. He also held the first AI conference, starting real AI research. In 1960s to 1980s was the early AI progress. This is where scientists build neural networks and expert systems that solve simple problems. AI started being used in areas such as medicine and games. In 1990, IBM's Deep Blue. The IBM's Deep Blue computer beats the world's greatest chess champion, Garry Kasparov. This showed that the computers could think and plan
Kasparov.
better than humans in some tasks. Then in 2010s to 2020s was modern AI. AI grew fast with deep learning and language processing. It generates AI tools such as ChatGPT, Siri, and familiar user interface such as Alexia, which can create text, images, and more. So AI had advanced from the 1921 up to the 2000s, where they started to ask themselves, can the computer think like a human? How are we about how they start to ask like critical questions? How can we create a artificial intelligence that can actually think and function just as a human being?
So applications of AI in everyday tools. So all of us here as young students, I know that we use social media. What AI does, it helps with curating your content page or your feed, your For You page, as we're all familiar with that. It helps with bringing suitable content based on what you like. Like, let's say that you like a certain type of content, then your whole For You page will be centered towards that, your interests. Or Face ID. AI helps with developing the facial biometrics so that your device is more secure, or whether you have a safe or anything. It helps with face-based authentication, and also search engine. It helps with filtering down information because, as you know, we have a lot of information available. It helps with, let's say that you search up cats. It helps with centering information, with filtering and centering information based on the questions that you ask.
Architecture in AI. AI is transforming architecture by enhancing efficiency, creativity, and sustainability. Key applications include, firstly, generative design. AI rapidly explores numerous design options based on set parameters. For example, we have Autodesk Generative Design, which produces multiple 3D structural design options optimized for weight and strength. Secondly, we have Building Information Modeling, also known as BIM. AI enables real-time updates, clash detection, and predictive maintenance. An example of BIM would be Autodesk Revit, which integrates architecture, structure, and MEP design in one model. Next slide. Okay. For energy analysis, you would have a moment. For energy analysis, an example of energy analysis, you would have yes, energy analysis. AI optimizes building orientations and material selections for sustainability. An example of energy analysis would be Cephara by Trimble, which performs early stage energy and daylight analysis directly in SketchUp or Revit, and also Energy Plus, which is an open source simulation engine by the US Department of Energy. Next, we have project management, which AI is used to support scheduling, resource allocation, risk prediction, and collaboration. Examples of this would be Procore, cloud-based management for contractors and project teams, and Autodesk Construction Cloud, which manages documents, issues, and workflows across design and construction. For visualization, which is widely known across anyone in this field of work, it is defined as AI-driven virtual and augmented reality, which provides immersive client experiences pre-construction. Some well-known examples of visualization would be Twinmotion, which creates real-time rendering linked with Revit, AutoCAD, and SketchUp. Lumion, fast rendering software for architectural visualization, and Enscape, which is a real-time rendering plugin for BIM software, great for walkthroughs and VR. Architects guide AI tools to ensure designs meet vision, practicality, and regulatory standards. AI complements architects' creativity rather than replacing it.
So here we have a short video that will help you guys in understanding how AI can be utilized in architecture. I'm going to go ahead and present that video. Give me a second.
Okay.
Tell me if you guys can hear it.
Yeah, did you remember to click share no, not hearing it. Share audio whenever you're sharing the video.
You guys should be hearing it now.
Before I start, I would like to ask you, how many of you are frustrated because of the red
Yeah,
tape you
one
have
more
to
thing.
deal
One more thing. When you're sharing the video, choose the optimize for video option.
Oh, yes, sir. I clicked that as well.
Okay, all right, cool. All right, yeah, man. Do you think?
Hello, everyone. Good afternoon. So before I start, I would like to ask you, how many of you are frustrated because of the red tape you have to deal with when you are just trying to remodel a part of your house? Exactly. I am too. I do understand you. That is why we are looking forward a new way to refine the entire design process. But first, we need to understand why the buildings are important. The built environment is the way we inhabit this planet, and we rely on architects to design our living spaces. And we want those living spaces to be creative, functional, sustainable, and resilient. Without asking how a building is built, we often overlook the frustration and the hardship going to a design process, and the tremendous amount of work that a person has to put on, even to design a single structure. And that is why even a single structure with not so many specialties takes around 6 to 18 months to complete. And this time frame doesn't even include special requirements like environmental regulations or natural disaster resiliency. We can change this with AI. But first, we need to redefine what AI in architecture means, because currently it is perceived as generating image renders. So this is what we know. But these static images are great, but they are not enough, and they are barely the scratch of a design process. We need an AI that is precisely developed to understand geometric systems that a building needs and responds in a way that the outcome will be a modifiable, editable 3D model, so that it will give professionals a jump start to actually build a project with AI. So imagine we are a room of architects designing an office layout with 2 executive rooms. So we will go directly from text to 3D model. Okay, so now we got the base. But as you can see, I don't know any of you, but personally, I have never seen an architect, an executive who wants a window in their room facing interior to the open space. So that's why, hey AI, can you modify the windows for me and remove that for me? Okay, now we are getting somewhere. I kind of like the design, the layouts, but there's something missing. We can add materials and make smart material choices using the AI inputs. But choosing a material is a delicate process. We need to consider not only the materials themselves, but the cost that they have, the cost to environment and financially. So we can leverage AI to automatically calculate the carbon emissions, and so that our designs will be net zero from the get-go, which is a mandatory aspect in over 140 countries. Also, AI can maximize the daylight usage, functionality, and the distribution of the furniture. Meaning, in conclusion, once something was taking 6 to 12 months, we can deliver that in days using AI. But this is just a part of the process. This is when you are building stuff that are in good conditions. But what happens when the worst of humanity comes? One day you can wake up in the midst of the dawn and hear from your home country that a devastating earthquake hit and caused millions to leave their houses and many thousands are under the rubble. This kind of situations are the places that we urgently need new constructions when we do not have the ability to wait for another 16 months to design and 3 years to build. And AI also can help us to become prepared for these kind of situations and also in the future even forecast and prevent these at all. So when you think of AI today, we can deliver all the 3D models, the material selections, carbon emissions, and the furniture layouts. But in the future, we will be able to do many more, from permits and zoning to resiliency and the structural analysis, concluding into, as I said, natural disaster.
So based on what was presented in the video, we can see how AI is used in architecture with making the design process a bit simpler, and it helps with concept generation and with displaying information. And it really helps with making the time taken for design a bit shorter and easier. So these are some examples as well as how AI is used in architecture. Another generative text generator, text and image generator is Midjourney. A lot of architects use that for concept visualization. You just enter a prompt and it will help you to, let's say, decorate a facade for a specific design. And it's also helpful within rendering software such as D5, Twinmotion, and Lumion. It helps with displaying your different concepts, and it also helps with the finer details and displaying those. Because as humans and with the design process so extensive, sometimes we may forget a few things. It helps us with remembering, keeping organized, and displaying those information. And it is also very heavily used in apps like Photoshop as well, and it helps us with rendering, displaying light, and adding people.
With every new software or new design, there is always advantages and disadvantages. Some advantages of AI in architecture are faster concepts creation. This is where AI turns text prompts into instant designs. Quick design options. It's easily generated. There are many alternatives to test its performances. It improves visuals. AI tool enhances images so architects can focus on design. Easier to use, it makes high quality renders possible without expert skills.
Disadvantages with AI. So seeing that it's still kind of a new technology and it's not yet at its prime. Well, it is currently at its prime, but there's still a few challenges with accuracy because in your prompt, you still have to be guided by an architect so that your concept images can show these details, or sometimes the information may be misleading or not 100% accurate. And also the disadvantage of AI is that some people, they will over rely on AI, and this can lead to some risks such as it may take out the necessary need for curating spaces for people. Let's say, for example, just like how a human, when we're designing, there are certain factors that we take in mind when designing for that person. AI probably will miss some of those small details. And ethics like image generations trained on broad data set raise questions about copyright. Let's say that after AI has given you a concept, some of what it has used to generate those concepts may have been copyrighted, and then you can get in trouble for that.
Ethical use of AI in the practice of architecture. An ethical challenge in architecture today is balancing AI-driven efficiency with the human, cultural, and emotional aspects of architecture. There is one will neglecting human experiences, culture, and social values. Therefore, the architect's responsibility is to human connection, not just functionality. To address this, AI should be used as a supportive tool rather than a replacement for human creativity or empathy. Ultimately, the goal is to encourage dialogue between AI-generated efficiency and human-centered design, ensuring that people remain at the heart of architecture.
Artificial intelligence is transforming architecture by enhancing creativity, efficiency, and sustainability through tools like generative design and predictive BIM. While still relying on human architects for judgment, ethics, and meaningful design, ultimately creating a future where technology and human imagination work hand in hand. And this is where AI in architecture is trying to be, where I guess people aren't trying to be over reliant where they have to say, okay, let's go on AI to create a design, but have it as an assistant to help in creating that design. This is the end of our presentation. Thank you for listening.
All right. All right, guys. Thanks much. We're gonna save the um the comments and the questions until after. We're just gonna jump straight into the next presentation. Next group.
Yes, sir. Working on it now.
Okay, yeah, man.
All right. All right. Good afternoon, everybody. We're groups number 6, and our topic is the use of 2D drawing versus BIM construction, working drawings production. First, is going to give introduction. Working drawings are essential document using construction to communicate technical details, design intent, others, engineering contractors. Traditionally, drawings were using draft, but today many have shifted to building information model BIM for greater accuracy and coordination. Compares drafting BIM are used to produce construction working drawings and their impact on the building area. First, I just want to share some videos of how 2D CAD was introduced and how BIM was introduced to. Hearing?
No, I'm not seeing. You need to share the window.
All right.
So you probably have to stop share and choose share again.
All right.
Or just share the computer screen if that works out better. So you don't have to, whichever one works out better.
The historical that got us to the point, and where is it going? Define all the.
Oh, okay. Wait, you have to share audio as well.
Can I share? I share an audio.
Okay. It might be your connection, or you have a bunch of stuff running. When you're sharing the video, you have to choose the option to enhance, or what's it again? Optimize for video, and check the audio option.
Sir, am I having issues? I don't know what's going on.
Oh, any other group members can help? They have the presentation they can share.
One second.
Or send me the link and I will play it from my end.
1 second. It's helping me.
Mhm.
I'm just trying out. She's on. Yeah.
CAD, computer-aided design. It's the cornerstone for how we design and build things. But how did it come into being? What are the historical milestones that got us to this point? And where is it going next? To find out, we're going all the way back to the beginning of time. No, we don't need to go back that far. Let's start in 1861, France. French chemist Alphonse Louis Poitevin discovers a process involving sunlight and a substance found in gum that allows original architectural drawings to be accurately reproduced. The process creates a negative copy, where black lines turn white and blank space turns blue, leaving users with a blue print.
Je le fais esprit.
Suddenly, designs can be easily replicated and distributed, allowing everyone to work from the same design without fear of errors in reproduction. It's no small coincidence that the second great industrial revolution starts just a few years later. In 1936, British codebreaker Alan Turing invents the Turing machine, which becomes the basis for the modern computer.
You're welcome.
Through the late 40s and early 50s, mainframe computing is introduced and goes commercial. And by 1955, transistors start replacing vacuum tubes, exponentially accelerating processing speed. Then, in 1961, renowned computer scientist Dr. Patrick J. Hanratty joins General Motors Research Laboratories and helps develop DAC, Design Automated by Computer. But it's Douglas T. Ross, computer scientist pioneer and father of computerized machining, that coins the term CAD.
Let's call it CAD. Okay, hooray!
Acronyms aside, to this day, it is Patrick Hanratty who's known as the father of CAD. In 1971, while Intel is busy introducing the microprocessor to the world, Hanratty introduces the CAD software known as Automated Drafting and Machinery, or ADAM for short. An estimated 90% of today's commercial drafting software can trace their roots back to ADAM. In 1977, CATIA, the first 3D CAD system, launches, running only on exclusive proprietary hardware. But by 1981, with the release of the IBM PC, desktop computing becomes affordable to the masses for the first time, and we see the beginning of the boom that would soon follow. On its heels, in 1982, John Walker founds Autodesk, and later that year introduces AutoCAD, the first significant CAD program for the PC, changing the world of design forever. Over the next decade, huge strides are made in CAD-based software. 3D modeling is introduced, opening the door to innovative design solutions, like BIM and digital prototyping.
Settle down, class.
Over the next few years, Autodesk introduces a steady stream of game-changing features, further embedding AutoCAD in the design industry as an indispensable tool of the trade.
Class dismissed.
In fact, in 2007, Autodesk ships their 8 millionth copy of AutoCAD. From 2010 on, advances continue to be made, including a web-based mobile version of AutoCAD that frees designers to work from anywhere, and Autodesk Recap, technology that allows users to create designs using real-world data captured from photos and laser scans. This is the evolution of CAD, from blueprint to desktop to cloud. Today, we see the Internet of Things continue to provide data to build smarter cities and better products. And eventually, generative design tools will use the infinite computing power of the cloud to change the very way we work, as our computers will begin to have opinions of their own and even begin to create designs for us. We'll have reached the point where the term computer-aided design truly means what it says. The tools of design have come a long way. The story of CAD is really just beginning.
All right, I will show now BIM video.
The altar right now.
Relax. I'm almost there.
We're like the friend who isn't always late.
You have the rigs.
CG United. Good like that.
Still having trouble?
Sir, I'm trying to share the other video.
Every one of the buildings behind me were built the traditional way, the old-fashioned way. Conservative estimates say that there is 30% waste in modern-day construction due to cost overrides and production errors. Hi, I'm Joe Binning, president of MEPCOR. Historically, buildings have been designed using drawings to convey the mental vision of those who are assigned to build it. Typically, there are hundreds or thousands of documents for each project, each a standalone part of the total design. The pieces require human interpretations to tie them together. Effective coordination between design disciplines and communication of the design to the field are a constant challenge. BIM is driving a revolution in in the construction industry. BIM involves using digital modeling software to more efficiently design, build, and manage.
I stopped sharing that one, sir, because you cannot really hear that video too much.
Okay.
Can you guys hear? Because I
Yeah,
can.
I could hear the video.
Oh, okay. I couldn't hear it. So. All right, I'm gonna get back to you.
Mm. Could anybody else hear it?
Yeah, I could hear.
Okay.
Yes, sir.
BIM breaks down barriers between disciplines by encouraging the sharing of knowledge through the project lifecycle. It encourages closer collaboration to integrate fabrication, construction, and operations. Using BIM improves constructability, shortens the length of time to complete the building, and positively impacts the bottom line. A BIM project is not drawn in the traditional sense with lines, arcs, and text in multiple documents. Instead, it's built digitally as a database in BIM software. Instead of having to look in separate drawings, schedules, specifications, and cut sheets for the information on a particular element, all the pertinent information is built into the intelligent object in the BIM model. Once placed in a model, it will automatically represent itself in any plan, elevation, section, detail, schedule, 3D rendering, quantity takeoff, budget, maintenance plan, etc. As the design changes, the object can adapt itself to adjust to the new design. This opens up enormous potential for exchange of information between project team members. A more collaborative design and construction project is the end result. BIM can extract data from design models and perform valuable functions quickly and reliably. This differs from traditional fragmented practices of numerous individual sheets of drawings. They can be viewed together to identify clashes and conflicts between architectural, structural, and MEP systems. A trend called Integrated Project Delivery, or IPD, leverages the power of modeling to facilitate collaborative decision-making. The opportunity to collectively resolve what are often contentious, expensive, and time-consuming conflict in the field in a non-confrontational collaborative process during design, while they are still relatively inexpensive to correct, is just one of the many benefits of BIM. The powerful combination of modeling and analysis tools with integrated tools and collaborative processes is creating a sea of change. As the adoption of these tools and processes spread, teams will continue to find new productivity-enhancing ways to leverage the power of BIM. MEPCOR, your U.S. outsource for BIM, can instantly enhance your company's ability to win and efficiently build more projects without the time and cost of any investment. For more information on MEPCOR or BIM, contact me, Joe Binning.
All right, so what is 2D drafting? 2D drafting, commonly done in CAD, computer design software, using flat two-dimensional drawings such as floor plans, elevations, sections, and details. The main features of CAD represents design using lines, shapes, and symbols. Each view, plan, section, elevation must be drawn separately. Common words for this is AutoCAD, DraftSign, and NanoCAD. Why 3D BIM? Building information modeling BIM is a process that creates a 3D visual model containing both geometric and data-rich information about a building. It allows multiple disciplines, architectural, structural, and mechanical, to collaborate in a single model. The main features are integrates geometry with information such as materials, quantities, and costs, automatically generates 3D drawings from the 3D model. So the common softwares that use this is Revit, ArchiCAD, Vectorworks, and Open Buildings. There's a comparison of 2D drafting versus 3D BIM working drawings.
Before you continue, I want you to stop the share and start it again. Continue. because it might be a little bit blurry
Okay.
just because of how Zoom works. Because you were just showing a video, it was optimizing the quality of the video. So just share again and then you continue so we can see the slides.
So this is a comparison of the 2D
Right.
drafting versus 3D beam
Mm-hmm.
in what aspect in the flow. 2D drafting is manual drawing and editing, while in 3D beam, central model automatically updates the drawings. And accuracy is there's a higher chance of errors in drafting, while in 3D is very precise and coordinated. Collaboration. In 2D drafting, separate files are made for each discipline, while in 3D beam, the shared model is used by all disciplines. Visualization. 2D drafting plots drawings only, but in 3D, full 3D visualization with materials. The output in 2D drafting is individual 2D sheets, while in 3D beam is 2D plus 3D plus data shared. So wait. Yes. To the next slide.
Somebody is to be reading this one?
Yes, the aperture is.
Okay. Yeah.
Sir, I just read it myself and
Okay, cool.
advantages of 2D CAD. Simplicity and accessibility. 2D CAD drawings are easy to understand and interpret by architects, design structures, and clients, require learning compared to 3D models. This improves collaboration and project delivery times. Efficiency in design and revisions. 2D CAD allows for faster alterations and updates, making it suitable with fast-paced architectural projects where quick changes are essential. It also enables rapid prototyping and exploring multiple design concepts efficiently. Cost effectiveness. 2D CAD solutions are more economical than 3D CAD since they do not require expensive hardware or software and fewer specialized experts. This reduces project costs and output time. Easy to share and print. 2D designs are portable, take less memory, and are easier to print, making them convenient for on-site use by foremen contractors where printed plans are preferred over complex 3D models. Faster processing and flexible design. Smaller file sizes of 2D CAD drawings enable faster loading, processing, and sharing. Adjustments to designs can be made quickly and flexibly, allowing experimentation with different options. Disadvantages of 2D CAD. Limitation. 2D CAD only flat dimensional views, depth, perspective, or rendering, which are ability to visualize architectural design. In other information, 2D drawing will not call the material properties, weight, spatial chipset as can provide, limiting this understanding. Lack of activity. 2D drawings are thick and cannot be manipulated or simply model of reduce and exploration abilities. Non-capability. 2D CAD cannot simulate real conditions, stress, strain, or environmental factors on architectural components, limiting performance analysis. time-consuming updates. In some cases, the sectional updating or revising 2D drawings can be error-prone and slow compared to 3D models where changes propagate automatically. Additional steps for rendering. 2D CAD lacks rendering features, often require exporting and converting to 2D before adding realistic visualizations, which lengthens our workflow. Limit design complexity. 2D CAD is restricted to simple geometric shapes and cannot easily be represented complex assemblies or intricate architectural forms. Now, advantages of collaboration allows architect engineers and clients share real information in one model, improve teamwork and preventing data discrepancies. Streamline planning. Digital models enable precise project planning, issue detection, and reduction in construction delays. Cost and waste reduction. Accurate estimation and clash extension reduce unnecessary expenses and material waste. Improve quality and safety. Early identification of potential issues enhances design quality and site safety. Sustainability. BIM supports energy performance analysis and circulatory by facilitating reuse of materials and reduce environmental impact. Facility management. Post-production BIM models provide critical data for efficient building operation, maintenance, and predictive issue resolution. Better representation and communication. Stakeholders through detailed 3D models, efficient clash detection between building systems such as structural, mechanical, and electrical components. Automatic updating of design documents ensure all stakeholders have the most current plans for sustainable, friendly building design. Disadvantage of being financial cost for in software license need for hardware require a financial costly for medium-sized firms. Training requirements. BIM technology is complex and evolving, demanding training and for staff. These are operational costs and requires time to build experience. Interoperability is compatibility problems may arise between different BIM software and software used by various trade partners and subcontractors, causing delays or data loss. Resistance to change. Successful BIM implementation requires buy-in across all project stakeholders. Some firms or individuals may resist traditional methods, leading to collaboration challenges. Limited universal adoption. Not all partners are subcontractors. Some subcontractors use BIM, which can result in inefficient workflow or wasted effort in some parties if some parties cannot utilize BIM models. Client engagement challenges. End users or building owners may not fully understand or utilize the BIM model post-construction, reducing the long-term benefits of the system. Technical limitations. Large BIM models can be computationally intensive, causing slower processing and affecting productivity.
You're muted.
Well, someone is supposed to be taking from me, sir.
Oh,
Can you hear me?
yeah, I can hear you.
Okay. Good afternoon. I will be presenting on models 2D CAD and BIM individually aid in the process of creating working drawings. So starting with how 2D CAD aids in creating working drawings is because of its precision drafting, which allows, is the screen change?
I'm seeing the title.
Can you change the screen, Evelyn, next? So starting with how 2D CAD aids in creating working drawings. It is because of its precision drafting, which allows designers to produce accurate line-based drawings such as plant elevation, sections, and details. And every element, the walls, doors, and windows, is drawn manually, giving full control over the layout and scale. It's also because of the ease of editing and duplication, which allows drawings to be easily copied, modified, and reused for similar projects or alternative design options, whereas with regular hand drafting, you cannot duplicate lines. You would have to measure and construct every line individually, but with 2D CAD, you can duplicate lines. Next slide. The limitations of this is that there is no automatic coordination, which means changes in
Yeah, I'm not hearing you. You're going out.
yeah, but okay. The slide is changing, that's why it's supposed to be on limitation.
Okay.
So the limitations of this is that there is no automatic coordination, which means changes in one drawing must be manually updated in all related views. So if you have added a wall in a plan, you would have to go through each section and elevation to add that wall manually in each of your drawings. Next. So how BIM, which is Building Information Modeling, aids in creating working drawings. It is a model, it has model-driven documentation. It means working drawings are generated directly from a 3D digital model that contains geometric and data-rich building components. This basically means that each element has a data attached to it. So a wall will be represented as a wall and not just a line, and windows will be windows instead of just a box. So in plan sections and elevations update automatically when the model is changed, ensuring consistency and reducing errors. So unlike with 2D CAD drafting, once you update something in one drawing, it automatically reflects in all of the other drawings. Next, how BIM aids simple. It also has integrated information, which means each component, wall, door, beams, contains embedded data such as material, size, manufacturer, and cost. And this supports more informed detailing and coordination with other disciplines such as structural, MEP, etc. Next, Evelyn.
It's next now. My internet is very, very slow.
Oh, okay. So there's also clash detection and coordination, which allows designers to identify conflicts, which is like a pipe or a beam. So in reality, a pipe should not be going through the beam. So on these BIM programs, it identifies these issues and indicates that you should fix it before producing final drawings, which improves constructability. There's also visualization and communication, whereas 3D views and renderings help convey design intent and spatial relationships that may not be clear in 2D. So BIM allows you to view a 3D model of the building you are creating or the structure, unlike in 2D programs. So the limitations now. It requires more setup and computational resources. The learning curve is higher and software licenses can be costly. Yeah, that's it.
All right, that's it for oh. Okay.
Good afternoon. My name is Keith Conreid. So we've been speaking a lot on working drawings, but I really just want to explain what are the needs for working drawings and give a brief analysis of what really are working drawings. So in architecture, construction, and engineering, working drawings are a set of detailed drawings that guides the process of erecting a building. They typically consist of plans, sections, elevations, and details, which shows dimensions, materials, construction methods, structural details, electrical and plumbing layout, and the finishing specifications. So the need for working drawings are a clear communication between the architect's intent and the contractor and engineer. So they understand up to the T basically what are the intents for the project and how to go about doing so. Accuracy in construction. They reduce the risk of costly construction mishaps or guesswork by providing accurate dimensions and specifications. So with the use of accurate dimensions and labelings and so forth, they basically provide as much accuracy as the workers and contractor may need for the assembly of this project. A cost estimation and bidding. So used by quality surveyors to estimate prices and by contractors to create bids. So the working drawings, as I said, basically due to their scale and the size of the projected construction, the working drawings now can be used to basically give a rough analysis of as to what would be the pricing for this projected construction. And legal and construction use. So the working drawings can be used in itself as a legal document, in contracts. So should any mishaps happen along the line between architect and client, these working drawings can be used as a legal binding to say, well, you had legally hired me to do this project. The shift from 2D CAD to BIM. From representation to information. 2D CAD focuses on drawing and visual representation. So that's lines, shapes, and annotations. BIM focuses on data-rich 3D models which contain information about materials, structure, cost, and performance. Improved collaboration. BIM allows multiple disciplines, architects, engineers, contractors, to work on the same integrated model, reduces errors and duplication of work compared to isolated 2D CAD files. Life cycle management. BIM supports the entire building life cycle from design and construction to maintenance and demolition. 2D CAD is mainly used for the design phase only. Visualization and simulation. BIM provides realistic 3D visualizations and can simulate lighting, energy use, and structure performance. 2D CAD provides limited visuals and requires separate tools for simulation. Automation and accuracy. BIM automatically updates related views, that's plans, sections, elevations, when a change is made. In CAD, all updates must be done manually, which increases the risk of inconsistencies. The challenges in the shift between BIM are the high initial costs. So BIM software such as Revit and ArchiCAD and hardware upgrades are expensive, especially for scenarios where you are no longer a student and have the privilege of getting a free student license. When you actually have to purchase these softwares, you find that they become a bit expensive. Training and skill gap. Staff needs to be trained in BIM tools and workflows, which takes time and resources. Resistance to change. Experienced professionals accustomed to 2D CAD may be reluctant to adapt new digital workflows. Complex implementations. BIM requires changes in workflow coordination and project management structures. Data management and interoperability interoperabilities. Different BIM platforms may not fully share data, causing compatibility problems between stakeholders, legal and contractual concerns. Ownership of the model data, liability, and intellectual property can become unclear. Large file sizes and performance issues. BIM models can be data-heavy, requiring powerful computers and strong networking. Standardization challenges. Inconsistencies between standards and protocols across regions or firms can cause confusion and inefficiency.
Okay. Now we'll be jumping into what software is used and the cost of each of them. So firstly, on the 2D drafting.
Jonathan,
Yeah.
you talk?
Yeah. Can you guys hear me now?
Oh,
Yeah, I'm hearing you.
no.
Okay. I think my mic stopped working for a second. So on the 2D drafting side, we have the AutoCAD LT by Autodesk, which we all know, which is a full-featured 2D drafting annotation, DWG format support. Less heavy than full AutoCAD by removing many of the 3D and BIM features. I think less known, or at least in our case, is DraftSight, which is a 2D drafting software primarily, with some versions that support limited 3D or constraint features. It's useful as a lower cost alternative to AutoCAD. LibreCAD is an open source alternative to AutoCAD LT, but is limited to 2D drafting only. BricsCAD is another 2D drafting software that offers full drafting 2D tools plus 3D direct modeling parametrics. On the 3D BIM side, we have Autodesk Revit, which we are all familiar with, which offers full BIM authoring, documentation, and collaborative workflows. ArchiCAD is another similar one with similar range to Revit, strong in architectural BIM collaboration tools, rendering, library, and content tools. Another BIM software is Autodesk Navisworks, which is a project review software used in engineering, architecture, and construction and the construction industry. It's used to combine multiple 3D files into a single integrated model for clash detection. And Tekla Structures was developed by Trimble, which is the same developers of SketchUp. It's used for design, detailing, and fabrication of multiple material structures like steel, concrete, and timber. Similar to what Keaton was saying about the cost, once you come out of school and you don't really have the opportunity to use your student license, they get quite expensive. Can you move to the next slide, Evan? So the next slide here highlights the cost of each. So Autodesk costs about, all the charges are in USD. Autodesk is about $530 per year or $65 per month. It has a 3-year subscription offer of $1,590. DraftSight is $300 or $299 for the professional 2D version and $599 for the premium version with 3D tools. LibreCAD is the only free software on the list of softwares that we have. BricsCAD has different prices for different versions. So they have a light version, an ultimate version, and different versions in between. But the light is $314 per year, and ultimate goes up to $1,180 or more per year for the ultimate. Revit, on the other hand, is $350 per month up to about $2,805 per year or $8,415 for 3 years. However, there is an educational version, which is free for students, teachers, and educational instructors, which is what Keaton was referring to. ArchiCAD is $201 per month for 1 year upfront. That's for the studio version. And there's a collaborative version where multiple people can work on a model at the same time for $237 per month. Navisworks is $135 per month, up to about $1,080 per year and $3,240 for 3 years. Tekla Structures, for a single user, it's about $200 to $500 per month, depending on the plan and configuration. So you can basically choose what features you want, and that generates the price. So it depends on the size of your building and the project requirements. There isn't a free plan, but they do offer a 30-day free trial educational version for students and educators.
Okay.
All right, this is the presentation.
Say again?
This is the presentation.
Oh, this is the end. Okay. Okay. All right. Thank you guys for those two presentations. So general comments. So I realized that for this week, there were some challenges in getting these presentations out at a particular quality, right? Just some general notes. So, anybody here plan to use, when you're doing your Design Studio final presentation, is there anybody here that uses anything digital or is just print and pin up? Anybody here ever show a video during their presentation? No? Oh, so nobody do no animations, nothing? Apart from just printing the work?
There's mostly just prints.
Mostly prints, all right. I remember when I was in school, I was always trying to experiment with some other forms. Currently, we present with prints, but we also present with models. You guys still have to like physically carry up your models and stuff. A third way is also with digital. I'm sorry. The reason I bring this up, guys, is that whenever you're presenting, right, whether it is physically, you know, like with a studio settings or digitally here online, you have to, there are going to be challenges anyway you take it. I remember when I'm doing my presentations and I need to show an animation or something that's digital, I have to kind of figure out, okay, how am I going to show it? Like, I can't use a sheet. I'm going to have to carry a monitor. I'm going to have to carry a TV. How am I going to play the video? Does it have audio? Do I need to play audio? There's all of these things. The same thing for presenting online. I realize some of you have some links that you show in some videos and stuff like that. You have to develop ways to streamline your presentation so that it is like consistent. There will always be technical challenges anyway you take it. Internet speed, videos, like automatically if you use a YouTube video, highly likely you're going to get ads. You are going to be beholden to the speed of your internet, that's for sure. And you're also going to be beholden to how the original author of that video laid out the video. So, you know, suppose there's a part of the video that is really critical to your presentation, you know, maybe 10% of it, but the video itself is 10 minutes long. You get what I'm saying? So what I'm saying is that when you have multiple ways of presenting in your presentation, you have to spend time to curate the information, right? If you plan to use a video, try and find some ways in which you can integrate the video in your presentation so that it is streamlined, so that there's a clean experience. Also, as a part of me marking your presentations, I also need to get the confirmation that you guys presenting understand what you are presenting. So it's always great to use like other content in your presentation, like videos, but at the same time, whenever you explain something in your own words, it gives an indication that there is some kind of understanding to what you're doing. So going forward, these are general comments. I know we have about 4 more groups left. So I need you guys to look into how you streamline your presentation. You have to include stuff that you explain in your own words. When I say that, that means that you have absorbed the information, you take from it what is relevant to your presentation, and then you curate that presentation. So for example, in the earlier presentations, I always give the tip that try and use bullet points as much as possible, which both of you did, guys that presented, use bullet points. But also, usually what you want to do is make the bullet points like a single sentence, if you can, and then you explain in your own words, right? So that it shows that there is an understanding of what you're reading, right? Because also with your audience, it helps to connect them to what you are talking about. Sometimes when you take a definition directly from the source versus you just explain it in a more layman's term, it's like people understand more. Oh, this is what this thing is saying. So I'm pointing, these are like general presentation techniques because you guys, let me tell you, architecture is an industry of, it's all about presentations. And think about it in the work context. Like if you are at your workplace and you need to show something to a client, or you might be doing a personal project and you need to convey an idea to a client. You need to ensure that when you're presenting, everything is streamlined. You understand? Guys, group 4 and 5, I mean 5 and 6, you understand what I'm saying here?
Yes, sir.
Yes,
Right,
sir.
right. So other general comments. Let me start with the last one first. So you do have the information. Like I'm talking about the difference between CAD and BIM. You do have the information, you do have the advantages and disadvantages, but you guys repeated yourselves multiple times. Like some of the advantages you mentioned in one chapter, you also say it in a different way in a different chapter, right? The general idea is that you guys are learning BIM now, right? You've been doing it from second year. But there's also something that exists called 2D drafting. And the dilemma that you guys are going to meet is that when you go there to work, you're going to go into workplaces that still are using 2D drafting. And maybe you might think that, oh my gosh, what are these people doing? They're drawing individual line work. But I'm trying to hopefully expose you to the reasons why they're doing this. So that is what I was hoping that that you would touch on in your presentation. Like, why? It's like, I would take from your presentation that 2D drafting is the way to go. Sorry, that BIM is the way to go. 2D drafting is not the way to go. So I went through some questions to you, right? Before the rest of you ask the questions, right? Do you think 2D drafting is still relevant in the production of drawings, and why? That is my question to you. I want you guys to earn your what was this criteria I have? Understanding. Yeah, I have a criteria named understanding. So I want to know if you guys understand the topic. Anybody can answer in the group, right? So Right. Do you think
Sir?
2D drafting is still valuable and why?
Sir? Can you
Yeah,
hear
go
me?
ahead. Yeah, man, I can hear you.
Oh, sir, I would say yes. I think it's good as a starter to do like small scale projects. So instead of going straight into BIM, because what I do is I normally draw like a sketching of my floor plan in CAD before I put it in Revit. So I would think as like a part of the process, I
Mhm.
think 2D drafting is still necessary.
Good. So I would want you even say that in your presentation, but it's all right. I'm asking you these questions because I am including your answers as a part of the presentation. So Davina said you personally you still use 2D drafting to get out simple things before going into BIM. Anybody else from the group? Do you think it's still relevant? You can answer no, you know. I'm not
Sir, yes, it is
okay.
very relevant,
Why?
important. I think it's an important step before, because as Avina said, is how she designs it. I think it's all of us. We have to put it first in paper and then put it in the computer after.
Okay.
Because
Okay,
we
cool.
develop first and then what has been developed, we just put it in the computer. And as it's like an aided thing, I mean the AutoCAD is an aided computing design. So
Mhm.
those programs help us to bring our project even farther away, I guess. So what we have, we
Okay.
just keep reproducing it. But it's an important step to do it, the 2D drafting first, using our hands.
All right. So two of the examples so far are kind of within the educational process. Is there anybody in the group that think that um like why are we still doing stuff in 2D? Like, is it still valuable? Remember, I am not campaigning for 2D drafting, There is no you won't be you won't lose marks if you're saying, but 2D drawing is so backward. Like, why we just don't do everything in BIM? Remember one of the first things we did when we were doing the major project is that we did the stuff in 2D before we did it in 3D. But one of the things I said is that this is because you are required to learn it in school, right? In the work world is a different ball game. So my
Sir,
question to you is that no, not in school necessarily, I'm just talking generally.
sir, I'm not from the group, but I want to ask a question.
Oh, you can
Do you
answer a
think
question with a
no,
question, but okay, go on.
no, I want to
Ask
ask a
away.
question first, sir. Do you think that you need to know how to 2D draw before you could 3D draw?
In the context of education and in learning architecture, yeah, you do.
Okay.
Right. You do. Because there's a process to understanding 3D where you need to make the transition from 1D to 2D to 3D. But so that is in the process of learning, which ties back into what I said a while ago. I said that you guys had to do part of the major project as 2D drafting because you are learning. Now I'm referring to in general, like in the professional world, like when you guys graduate from CSA, or when let's say that you graduate and somebody come to you and say, I want to redesign the facade of my house. I want to make it look nicer. What is your personal opinion? Would you regard 2D drafting valuable? Is it a part of how you would do the work? Anybody?
Sir,
Mm-hmm.
sir, I personally would ask him. Sir, so I wanna ask if it's valuable, but more if it's the right tool for the task, sir, or the right tool for the job. Because I want to find out who they can ensure that um this thing. You can you can do the same thing with tool drawing as using a 3D program. So but using 3D drafting, there are numerous amount of things that you can find out, like charity creation. It's a lot of things you can find out that is also there with our program that you can this better.
Oh, you're kind of going in and
So I
out.
think it's apps.
Yeah. Oh no, we lost him.
I think he said his audio was his internet was a bit unstable, sir.
Yeah.
I am from the group, sir.
Okay,
But
cool.
as it relates to 2D being relevant or not, sir, I'm a bit in between, sir. Because how I develop my projects personally, I like to use solids. So
Right.
I would perhaps use even some PVC and create like a semi block, representing a building. And then I could use stuff representing shading devices and see how light plays on those shading devices against the building. So that in itself is giving me a miniature 3D representation of what that projected shaded device for a building can look like. So even though drawing it on paper is one thing, or creating a 2D version of it is one thing, I feel like having a actual model of it, a physical model of it, not just on a computer, but an actual physical model of it in a smaller version or at a smaller scale, where you can actually have certain conditions, test against it. You get a clear vision really of what it is that your design intent is or should be in the direction of.
Got you. Cool, good answer. Lawrence. Oh yeah. Hold on, before Lawrence. Shane, yeah man, you got disconnected. The last
It's kicking out every time, sir. But I'm saying that it's not a matter of it's if it's valuable, but is it the right tool for the job?
Yeah, man, I got that. And I love that answer. Lawrence.
Sir, I can answer even though I'm not from the group.
Yeah, go ahead, since we kind of discussed it.
All right. So for me, I think 2D drawings are very vital. They are like a more refined way of sketching. And for any artist, a sketch is very important. That's how you analyze or read a space. And that's like you taking your sketch now and then unfolding it into, it's like having a box, a 3D box, and then unfolding it, finding the necessary layers before putting things together. So it is like the foundation of designing for
Right.
me.
Right. Good answer. And I can pick out certain things from each of those answers. Time is going, so I'm going to do it quickly. And I specifically want to expand on this topic because, as I said, when you guys presented, I know you were kind of reading and doing advantages and disadvantages and that stuff, but I want us to have a more like practical discussion and really 2D versus 3D. So there's a couple of things. Firstly, as Lawrence was saying, as an artist, sometimes too much information can slow you down. Sometimes it's easy to work out something in 2D because yes, there's other things to consider, but it's almost like when you go to draw in Revit, you need to know the height of the wall, what layer it is, what materials it has. In some cases, Revit won't even make you draw some things unless you know other information. So in a way, it's two sides to it. A 2D doesn't have all of the information as a 3D, but at the same time, the right tools, another person mentioned the right tools for their task. Sometimes if you're sketching, you might prefer to sketch in 2D because the way that you streamline your process needs to be in this limited way to not take in too much information so that you can represent it. So sometimes you just want to look at this elevation. And then you look on the other elevation and then you move to 3D. Some persons, it's the inverse. Some persons want to see everything in 3D one time. Now, let me carry it back to what the presentation was saying. Now, this is more as it relates to construction drawings. Now, there's a dilemma as it relates to BIM and 2D drafting. And you guys are going to face this is an important dilemma because you guys are going to face it. And what it is that when you leave CSA, most 99% of you will not know how to do construction drawings, right? Yes, you can do design drawings, and design drawings is like what we present in Design Studio. You do plan, elevation, and some 3D. Those are design drawings. But most times when you work in an office, you're going to be required to do construction drawings. And what happened is that, we don't teach construction drawings in CSA, but in architecture school in general. Most architectural schools don't really teach construction drawings, as in specifically, right? They kind of teach more design drawings because, so construction drawings is something that is as like it can be taught by itself. And what you find is that a lot of the persons that know how to do construction drawings are doing construction drawings in a 2D drafting program. And that is simply because BIM has not been around that long. And this is why sometimes what's probably going to happen is that when you go to work in an architectural firm, the person that has the most experience in doing construction drawings is probably going to be doing it in 2D CAD because 2D CAD has just been around way longer. And you guys are going to have to be the ones to figure out, how do I do construction drawings in BIM? Because remember, you're not going to necessarily learn it in CSA. And a lot of people end up defaulting back to drafting because the persons who you're learning from, unfortunately, is not doing construction drawings in BIM. So this is like one of the challenges that you are going to meet. So you have all this nice Revit knowledge, but when you go in the offices, it's kind of like what you do is not what can be submitted for approval so that a client can get them drawing built. And that is something that you guys are going to have to figure out, right? Because most of the persons with experience are not doing construction drawings in BIM. That's just a reality, right? And at the end of the day, Revit is a kind of program that it requires it's a totally different approach for you to produce drawings in Revit compared to produce drawings in a 2D drafting program. And I'm not just talking about Revit here. Same thing with ArchiCAD, same thing with any BIM software. When you want to draw a line in Revit, you have to go into properties and you have to change the type and you have to when you want to draw a line in a 2D drafting program, you just draw a line and change it. So there's two completely different approaches and you guys are going to have to navigate that. So that is kind of the essence of what I want you guys to be aware of when we're talking about 2D drafting versus BIM. There are some cases where you might want to do 2D drafting. We spoke about that, designing, blah, blah, blah. And there are some cases where it's just, yes, the BIM can do much more detail, much more robust, much more information-rich construction drawings. But how do you achieve that? You guys are going to have to dig deep and learn that. Most of you learn it on your own. And there are very few people who actually know how to do this in BIM. Very few. But your journey begins, guys. All right? That is the big dilemma with 2D drafting versus BIM. And most of the stuff that you present is showing that BIM is better, in every way. But the thing is that you have to learn how to use it to produce the drawings, and that is going to be a challenge. So I just wanted to expand on that a little bit. As it relates to the other presentation, this is with the AI. I also want to bring to kind of add a practical spin on what you guys presented. In my opinion, you guys, this is what, topic 5? Yeah, 5. So you guys did present on AI, but in my opinion, there is so much more things I wanted you to touch on, right? Yes, you can generate images with AI, fine. Yes, you can use, fancy architectural software to like to help you design, right? For example, let me share my screen. I was seeing if you guys would touch on this one. Hold on, here we go. And I'm going to put this thing here. Right. One of the ones I'm always fascinated with is oh my gosh, it just escaped my brain. Right, test fit. Right. So for example, like test fit. These guys here, and I don't need to explain what this is. You just need to look on this. You just need to look on this video here. That's like on their website. And what do you notice this video is doing? Anybody from that group? Talk to me. What is this doing?
It's like it's generating different formats or different layouts. For, I guess, a parking garage, and how does it relate to everything else?
Not necessarily parking garage. This is actually units. Let me see if they have any more videos here. They do have a video
Using
here.
our like mixed development.
Right. So what this is doing, and the key word here is in real time. Plugging in a bunch of values. I have 100 units, and I need a 200 car parking lot. I need each unit to be not bigger than X, and each of them must have a balcony of Y. And you plug in those values and you draw some boxes and you move things around, and they're editing in real time. There's much more to this, but I don't want to dive too deep in it. So yes, we can talk about all these fancy features with AI, but on a more practical, everyday level, guys, the power of AI is not just wrapped up in these fancy features or in Midjourney and generating crazy images of buildings, most of which isn't even necessarily logical. So for example, I always have this example here. Where's my AI in architecture? By the way, I do a topic on AI in architecture, but that's in 4th year, so I can just give you a glimpse of some of the things we talk about. Like, look at this model I created in SketchUp, and I said, I want you to give me a 4-story boutique hotel, blah, 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 blah. And it gave me a couple options here, but using my exact massing model. If you notice, this is what the massing model look like. So, same thing. So yeah, you can use AI to deduce things. Some of them are not exactly logical. You know what I mean? They're not exactly logical, this column here and how does this stand up and whatever, but it's good enough for idea generation. Fine. So you touched on those 2 ideas, and there are much more tools apart from Midjourney that do this, but fine, I won't even go into that. What about the everyday use? Like, I'm sure you guys have come into a scenario where you are working on something in your design studio. Maybe it's your housing project or something, and you said to yourself, no, but if I turn the units this way, they will be able to see into the courtyard or whatever the reason is. And then you might turn to your friend and say, what do you think of this design? Like any of you ask each other questions during your design studio process? Anybody?
Yes, sir.
Right. And this is one of the reasons why you have studio, because you're all there working on something and it's like you're scratching your head over this thing for like 2 hours and you say, yo, what do you think about this room? You know, what if I put the bed over here? And what I'm trying to do, one of the things I was looking for you guys to talk about in AI is that this is some very basic questions that you can even post using AI. You can use AI to help you figure out this. You can say, for example, you started the presentation with saying, we'll use chat. Chat is not just for asking it to write your essay for you and then you copy and paste it and it sounds really bad. No, chat is not just for that alone. You can reason with it. You can say, hey chat, look at this screenshot. I have my bed over here on the left and I have a window over here, but I need to fit 2 beds in this space, but the space is only X and Y. What do you think? Like, this is a question you would ask your brethren next to you, and your brethren would have sit down and say, boy, I don't know, maybe I would put the bed here and blah, 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 blah. AI can also do that as well. Like, most people still regard AI in this kind of taboo form. Like, oh, look, I did this all by myself. I didn't use any AI. And they feel proud for saying that, even though maybe they did use the AI. But it's like, we're at the stage where we need to move past that now. We need to, most of you, if you're looking for something, you Google it. And it's the norm. You know what I mean? You Google it and it's the norm. AI is there not for just the gimmicky rendering of things that look nice but maybe not exactly work, but it's a good inspiration starter. And AI is more than the high profile, we can plug in values and it design a room for you. That's another aspect. I would say the everyday use of AI is in the regular things that you guys do every day. Like a question that I just like that example that I just gave you a while ago, right? Even in identifying something, guys, like if I bring up chat now, and I'm trying not to run out of time, but at the same time, these are some of the things that I'm hoping that you guys would touch on in the presentation. So if you didn't touch on it, then it's my responsibility to show you. If I said I don't know, wall section showing railing, right? Let me just see if I can find an image. I'm kind of making this up as I go along, but let's say that even you did I say railing? Yeah, wall section showing balcony railing, right? And even something like this, or something like, let's say you're looking up something on balcony railings, right? You're saying like, yo, I really love this railing design. Let me open it in a new window. I want to use a railing style like this in my project. But then, like, maybe you're saying, what is this? Is this stainless steel? And how does this work? Like, these everyday questions are things that you can just take a screenshot of. And you can just drop it in chat. Come on, paste. Oh, I have to save it first. Fine. I'll just add it here. Add a picture. Hold on. Hold on. I'm going to just drag it from my desktop here. There we go. I don't know, Zoom not allowing me to drag in this thing for some reason. Hold on, let me close this and go again. Oops, chat. Why are you not dragging? Come on. A new chat. No, not temporary. It's signed in. Unavailable. I don't know. Maybe there's an issue with it now. Yeah, sometimes these things are unavailable. Yeah, it says that add files is unavailable. All right, let me just jump over to another one. Let me use Grok. There we go. Signed in, good. Right, I can drag that image in. Okay, Grok is working now. And I can say, you know, how is this railing manufactured? You know, and you can like have a conversation with it, and it will look at what it has in the image and it will give you some answers. It's almost like if there was a student lecturer sitting beside you and you say, I want to use this design, but I don't understand how it works. I'm encouraging you guys to like use AI properly, not in some highfalutin way of generating images only, or not in some fancy software, fancy service that we can afford, but in some very basic, normal ways with questions that you would ask just anybody. The fact that you can, if you don't know what something is and you want to know more about it, use the AI as well. So I just want to bring to you that you can some more, I would say, normal low-hanging fruit, some normal ways in which you can use AI in everyday architecture stuff, right? It can also help you with decisions, like we're just talking about putting the beds in different places, but it could be like other decisions, like I want to put a 3-story building here, but I think a 2-story building would work better. But then if I do 2-story building, I'm not able to fit the same amount of units. What are some ways that I can still fit the units but have the building 2-story? You know, like just basic questions like that. So I'm just saying that you can use the AI to do some of those things. All right. I think I've gotten up most of the group 4, 5, 6. Group 6. You understand what I'm saying, guys?
Yes, sir.
All right, cool. Also, what I didn't see from either groups was like, what about any demonstrations, like from group 6? This is an example of how I use AI in architecture. You know, from group 5, this is a project that I chose to do in 2D because of XYZ reason. You know what I mean? Some down-to-earth examples. Going forward, for the other groups that we're going to present, I want you guys to not just present on the highfalutin thing that's you know, that's available if you had limitless money. I also want you to focus on the everyday things, the things that you use in CSA all the time, things that you use as an architectural student, things that you think can work locally. I need you to bring it down from earth whenever you're presenting on your topics. All right, very quickly, can we get some questions? Group 1, question, go ahead. Going once.
Sorry, sir, I'm here. Are you hearing me?
Yeah, man, I'm hearing you.
Wait, could you give me a second, please?
Oh, let me stop this share. All right. While group 1 prepares their question, group 2, any questions from group 2? Going once.
Sir, I have my question now.
Oh, group 1 question. All right. Let me
Yes.
get my thing out.
Which
group are you asking?
I don't know, which group is the group that Jules was in, that Evelyn was in?
That's the construction, the 2D versus BIM.
Okay, so my question is, what's the main difference between 2D drafting and 3D BIM?
That question is not valid. Why? Tell me why. Because they did answer that in their presentation. Right, Evelyn?
Did they really though?
They-
Did they?
they-
Did they?
did you, Evelyn? Did you really?
Yeah.
Thank you. All right, I'm going to circle you back. So, yes, you're ready. Group 2.
Yes, sir. I have a question for group 5.
That's AI.
Yeah. Basically, with improvements to AI in the industry, should architects fear being replaced by AI, or like others in the industry, like interior decor and all these types of design industries?
That's a good question. Go ahead, Group 5.
Okay, so should architects or anyone in the industry fear AI? I
Being
would say
replaced.
AI, yeah, being replaced by AI. I would say AI is more of a tool that would help to improve their skills or productivity, because the use of AI depends on your skill level. And if you're not very proficient in your field on how to manipulate the AI, the outcome wouldn't be as how I say, as profound as you doing it on your own. So AI is mainly just a tool that can be utilized and which would improve various aspects of your work, but it isn't developed enough to replace humans, because architecture is a field that depends on human traits that AI could never really create by on its own.
All right, cool. Cool. All right. Hold on. Ansel, you are from what group? Group 2?
Group 2.
All right, cool. So Group 2 has asked their question. Group 3?
Hi, sir. We're here. We have a
Yeah, go
question.
ahead.
The question is for group 5. I believe that's the AI group.
Right.
If AI is so effective, then wouldn't it be a good idea for it to be included within our schooling? You know, for it to be more accepted, for us to be taught how to utilize it so we can take better advantage of it?
Good question. I wish I could give you more points for that, but I can only give the amount on the thing.
To answer that question, I would say no, because as students, we would actually, well, I'll just use my personal experience as an example. If I had the choice to use AI, most likely I'd use AI because it's just more time efficient. I wouldn't have to spend much time on the work itself. So much of the personal or much of your personal preferences wouldn't be placed on the design. It's going to be mostly prompts that you
What
put
did you
in.
ask?
She asked if why wouldn't AI be implemented into schooling if it's not a huge risk of it being replaced.
No, well, it was more of why is it not implemented in schooling since it's so prevalent? Was that the question? Let's hear from the horse.
Yeah.
Horse.
Hey, hi.
Yeah, man.
Yeah, that's what I said. What you said.
Okay. Why is it not used more in school?
Right.
Okay, right.
And like you have to remember too, like to use the AI for architecture correctly, you have to know what specific to ask it. So without that knowledge that you should be learning in school, you wouldn't be able to, I guess, use the correct prompts to inform the design. You have to learn it. So if AI was supposed to be implemented, then that part of schooling wouldn't make any sense because it is going to take away I guess, the foundation of what design is. So
Okay.
yeah.
So you're saying that if we taught it in school, then you could just prompt anything you need to know
without
which
having to learn
means
it.
without having to learn it. Okay,
Yes.
okay. I see your point there. I see your point there. Well, that is some of the dilemma that we are facing. And there is some good information out there. We don't have the time to dive into it right now. But I will point you there have been some studies done on students who use ChatGPT, and there was one done recently with MIT about that it can deteriorate your brain. Don't think of it too science fiction, like deteriorate, like it just evaporates, but more of a really long term, you know, your brain would not be as active if you used it as much. I don't know if there's a double-edged sword, because really and truly there are a lot of people that don't really know how to use AI. I mean, chat is free and Perplexity is free, and we jump into it, and occasionally we ask it things, but there are levels to using AI, big time. And most people are not really aware of these levels. And in a way, not knowing about them could easily mean that you could get left behind, not replaced as with the first question, but possibly left behind. You know what I mean? If there's a design competition and the person with the most design options, is more likely to win the competition. You use AI to help you to get the option. So you have 10 options for your design, but other people only have 2 because that's what they could work out with their own brain. Then it is just more likely that the person that have the 10 designs will go through. You know what I mean? So that's a really simple example, but yeah. I think the answer to that one is going to be we are still searching for the answer. Because obviously you can't not teach or talk about it, or else you'll be left behind. But do it too much and you won't learn anything. Anyway, next question. I won't linger too long on that one. We're already out of time. That was 3. Who was that? That was Graham for group 3. Am I right?
Yes, sir.
All right. So group 4. Group 3.
Yes, sir. All right, so my question is for the group 5 that did AI. So
a lot of AI questions. Okay.
Yeah. So I just want
Yeah,
to
go
ask
ahead.
something like, how would current advancements in computing power and developments in technology influence the growth of AI in recent times and in the future coming up?
So let me understand the question. How will the development of what?
How would the development of how advancements in computing power influence the growth of AI in the coming future?
Okay. All right. Go ahead, AI group. Answer that one. How does recent development in computing enhance the development of AI?
All right. So with the advancement of technological devices, AI will be able to process even more, let's say harder questions or even generating certain concepts. Let's say that, for example, you ask ChatGPT something. Right now, currently, depending on how deep you go, you realize that ChatGPT is limited in certain things that it can produce, and sometimes it's not as accurate. So with the advancement of computer power, then you would be able to then do those tasks efficiently and more accurate.
Well, let me add to that. Right now, one of the huge disadvantages with using AI is that it hallucinates. If you are trying to use Revit to draw a wall and you're like to draw a wall with a butterfly in it. I know that's a weird thing, but let's say you're trying to do that. And you like go to chat and say, how do I draw a wall with a butterfly in it? And chat say, oh, that's easy. Look under File, Edit, and there is a butterfly button. You get what I'm saying, guys? Like there is no butterfly button in Revit. So that's why you call it an hallucination. So as technology improves more, the hallucinations will be less, which will mean you will get more accurate answers. It would say something like, there is no butterfly, there's no way to draw a butterfly in Revit, there's no butterfly button, and it won't make up things and tell you. So that's just a quick add-on to that question.
Sir, so those hallucinations that you mentioned, won't that require advanced algorithm?
I don't know if the sole requirement of that is advanced algorithm. Maybe it's a combination of things. So for example, you need more data. You need more, it needs more data on Revit for it to more accurately answer questions. Better algorithms in how it predicts the answers. That would also help. But you have people working on that every day. So both on the hardware side, in order to get more data, you're going to need more equipment, you're going to need more energy, all that kind of stuff. So everything is increasing, right? But the question was more, how does increasing the technology around, the hardware around computers, how does it improve AI? So the general note is that it will reduce hallucinations. Better algorithms overall alone won't reduce it because you need more compute power to also reduce it as well. All right, Shane? Not that I'm an AI scientist by any means. So let me put that out there.
I was just thinking about it that it will require more extract the capability from the same computer resources.
Right. And if you heard in the news, like this is old news now, where China developed their own version of ChatGPT called DeepSeek. It's not that they had more computing power, they just had better algorithms. So that does help, but also compute also helps, so both are required. All right. So we're going to skip 5 and we're going to skip 6 because you guys presented. So 7. Seven going once. 7 going twice. Okay, 8.
Sir?
Any questions from group 8?
Oh, sorry, I'm in group 7.
Okay,
Sorry.
go ahead.
Sir, questions for who?
Meaning you're asking the questions. You're asking a question to either the group that presented on AI or the group that presented on drafting. Do you have a question to ask that group that presented?
So I have a question. I'm in group 7.
Okay, go ahead.
So this is for the one Evelyn's group. So how
Evelyn.
has BIM changed the role of architects and drafters?
Did she answer that?
I'd like to know the answer again, sir.
Oh, all right, fine. Go ahead, group 6.
What is the question again?
How has BIM changed the role of architects? Was that the question?
Yes,
right,
and drafters, yeah.
Right.
Well,
architects and draftsmen. How has it changed the role of architects and draftsmen?
Well, BIM has shifted the architect's role from just producing drawings to modeling data-rich models and coordinating with other disciplines. So it's basically
Good answer.
is so well drafters they understand parametric modeling, information management. So it's like the focus is now like a drawing production. It's like a lot of people working on it, so it's easier, I guess.
Right. I like a part of the answer that you mentioned.
Okay,
That
thank you.
the architect's role is now shifted to managing data. You know, most firms who manage to switch to BIM, because most firms want to, especially local there in Jamaica, most firms want to, but in order to properly switch to BIM, you're going to have to be thinking about collaboration, the same kind of things you guys learn about in school. You know, collaboration and how do you work with multiple persons on a project, and how is the engineer going to get the file, and does, what is an IFC file? How do I export in different file formats? So the role of the architectural firm now is you're in this digital realm. You know what I mean? Managing data. More and more. All right. That's a question from group 7, right? So group 8 now?
Yeah, a question for the drafting group.
All right, cool.
Yeah, so which design elements are necessary to consider when shifting from 2D drafting to BIM? Or like what considerations need to be made?
Switching from 2D drafting to BIM.
Mhm.
All right, that's a good question. Hopefully you can summarize that one, because the answer can
Okay,
be
so can be what?
yeah, go ahead. The answer can be long, so just summarize. We got an overtime.
1 second. What's that question again? I'm not really hearing.
What are the things to consider when you want to move from a 2D drafting workflow to a BIM workflow? I think you kind of did mention that from memory, a little bit in the presentation, but go on and answer. I'll make it go on.
Somebody else from the group that wants to answer the question?
Can you guys hear me?
Yeah, man, I can hear you, Davian.
I think one of the main things you'd have to consider is your workflow when switching from 2D drafting to BIM, because in 2D drafting, whereas you use lines to represent each element, in BIM, you'd have to select each element type to do a different thing. So you have to select walls to be walls, not just a line. So in your workflow, you can't just use one element for everything. That's something you have to consider when switching.
All right. I mean, that is true, though I think a more appropriate answer would be more of, if you are in an office that is thinking of switching from drafting to BIM, BIM software is a different mindset. And this is why when you guys, you realize more and more when you go out there and starting to work, the persons who have the knowledge of how to produce drawings, it's not as easy as just to tell them, oh, just do the drawing in BIM, because the approach of BIM is totally different. So training is one of the most tricky things. And the other thing is acceptance. I'm telling you, like, if you train people to use BIM who have used drafting for years, nothing will work until they accept it. You know what I mean, guys? You can go to school and I can show you how to use Twinmotion and say it's the best program in the world and whatever. But you don't have to use Twinmotion. You don't have to accept Twinmotion as the program. You know what I mean? You can still get rendered images using other programs. So drafting, if the objective is to submit your drawings for approval, some people would rather go through paint, don't care how you sell it to them. They said, no, I'll still rather update every elevation, draw every line in this louvered window, I will do it because it's simpler. So training and acceptance is going to be one of those things because the way how BIM works is different. You guys kind of grow up using BIM as your default, so it looks weird for you to draw every line on a louver, right? It's probably weird. Or to update every elevation individually. You know, you probably look at somebody doing that and say, are you mad? But yeah, that's at the end of the day, they're not mad. It's just how they learned it. You know what I mean? So anyway, that was just my addition to it. I think we're at what, 9? Question from group 9? Going once, going twice. Question from group 10? Going once, going twice.
Sir, I have a question.
All right, Joel from group 10.
Yes, so my question is, do you see a future where buildings are designed entirely by AI, or will human creativity always be needed?
Huh. All right, that's a heavy question. Go ahead. Yeah, group.
Can you repeat that question, please? I didn't hear all of it.
Do you see a future where the building will be designed completely by AI? Or will we always need human intervention?
I feel like when it comes to building designs, you can always look at the facts and the logics behind it and say it is very clear cut to design a building. But when it comes to architecture, human influence and emotion and all of that kind of plays a crucial part in designing buildings, because buildings aren't just structures to work or reside in. It's also, it speaks towards your way of life and how you take on your daily ritual. So as of right now, AI does not have the capabilities to replicate human cognitive thinking to that degree. And as of right now, it just seems like it's a tool because it's not fully developed, and it can also make mistakes. So.
Okay. All right, cool. Good answer. Good answer. As of right now, who knows what the future will hold? Lewis, you want to try again? Going once, going twice?
Oh, yes, I'd like to try again for the same group.
Too much AI questions, but go on, because we're on the last one.
Wait, sir, give me a second.
All right, so guys, today is the final unveiling of the topics, right? So topic, here we go. Oh no, not that one. We are looking at, where am I? Here. All right, topic 9 and 10. Who did I see here? Watson, Foster, are you here? Anybody from group 9? Yes, no. Oh, okay.
Sir, I have a question.
Oh, okay.
Do we have to upload this presentation or somewhere, or send it to you?
Yes. No, there's a upload button. You have to upload it before you get your grade. So yes.
Where do we upload it though?
When you go to the website, yeah, when you go to the website and you click on class and presentation assignments, there is a submit presentation right here. All right.
Excuse me, where was that class presentation?
It's, you see, yeah, it's right here On the presentation assignment, 20%. It's on
Okay,
the
thank you.
handout.
Okay, thank you.
Louis, you have a question now?
Yes, sir. This is for the same group. Can BIM completely replace 2D drafting? And if they answer that question, let's pretend like they didn't answer that question. Thank you.
Can BIM replace 2D drafting? Go ahead.
I would say not entirely because while BIM dominates large and complex projects, 2D drafting still remains, valuable for, I would say, small scale or quick design tasks. Also, I think because 2D CAD is faster and cheaper, I'll say, also simpler or straightforward work. So I'll say it won't completely replace 3D drafting, but at the same time, we know that BIM is extremely powerful tool for large architectural firms. So for what I've seen experience so far, and even in a large firm, they still use it. So,
All right, cool. Okay, good answer. Yeah, at the end of the day, BIM is more expensive and more complicated, and there might be persons that still prefer to use 2D CAD. Right, so it may not fully replace it, at least for the next immediate future. All right, so that was question from group 1. So we finished with questions now. Hold on, let me just record that. That was from group 1. Okay, guys, so very quickly, the last two topics. Right. Where were we? We were here. Yes. Okay. Topic 9 is discuss the use of 3D modeling in fractal architecture. Right? Come on, where's my thing? Right? So discuss the use of 3D modeling in fractal architecture. Of course, one of the first things you're going to have to find out is what in the world is fractal architecture, right? And when you find out the answer to that, you might realize that, oh, I know what it was all along, right? You might come across it in your design studio already, or in history, right? So fractal architecture is basically a type of architecture where the structure is shown a lot and it has repeating structure, right? So for example, you can see here the Eiffel Tower, right? And the idea is that it is trying to use structure in a similar way that it works in nature. In a lot of times it's trying to replicate that, right? And it's usually used, like there's usually a very practical use of it. So I want you guys to kind of explore what that is, right? I don't know if some of you already are doing designs where you're thinking of using that kind of structural design. So for example, you can see here how a tree works and trying to use that to influence the way that this building is held up. So that's kind of what fractal architecture is. And I'm just giving you a brief example, right? Just so to lay the base of what it is. Now there's a bit much more to it, and I'm going to leave you guys to investigate it. I want you to look at what is the relationship between nature and fractal geometry, right? How has it influenced architectural design? What architectural design examples can you show me? Bonus points to you if you find some local ones, Can you find any local ones, or I would say in the Caribbean, that you think utilize this kind of architecture, right? Then now, how in the world can we use software to do fractal designs? I remember that there was a student one time that had a fractal design in their structure, and I was helping them to do representation of that. I'm not going to tell you the software I used. I want you guys to figure that out in your presentation, right? The differences between intentional and unintentional fractal design, right? Because as I said, fractal architecture has different depths to it. So I want you to tell me the differences between the two. If you can find some examples, that's great. And I'm going to end it there. I'm not going to give you any more tips. Definitely show me some examples of it, right? And if you can find anybody who has used it in their design studio or thinking about using it, that would be a great addition to the presentation. All right, that is topic 9, and last but not least, topic 10. Well, we're really going over time here. Explore 8 types of architectural visualization techniques and how they are used in architecture, right? So architectural visualization techniques, right? And for those of you that have that group, here we go. Right. 8 types of architectural visualization techniques and how they're used in architecture, right? And so, for example, what are the different techniques? So, for example, you might have photorealistic, hyperrealistic. I'm not showing you anymore. You get the idea though, guys, right? I want you guys to go ahead and do the research. Tell me the different types of architectural visualizations, and what I want you to do is to, you know, as usual, define what it is. I want you to, I want you to tell me, whether through demonstration or example, what types of techniques have you used, meaning persons in that group. After you find out what are the types of visualizations, I want you to make sure to include the types of visualization that you have used. If you can find examples, that's great, right? What are the programs that are linked to producing particular types of visualization? So for example, if I'm doing photorealistic, that one is pretty easy. What type of programs would I use to do that? But what if I'm doing hyperrealistic? You know, what is hyperrealistic? What, you know, photorealistic and hyperrealistic, are there differences? Plus there are others. I want you to do 8 of them, because there are going to be more than 8. But I want you to pick 8. I'm not going to tell you, you know what, I think I should maybe at least share them with you, because I don't want you to go too wide. You know, collage, that is another interesting one. Some of these you've probably already done already, right? And you don't have to do the ones that I show you here examples of. If you, for example, one is called Mad Max. Like, I don't even know what that is, right? I'm sure when you go down the rabbit hole, you're going to find many different types or styles of visualization. I want you to choose only 8. And for each one of them, tell me, like, when would I use this? Why would I use this style? When is it best used? What type of software would I use to produce this architectural style, and so forth? The key thing is to remember only 8 of them you are to pick. All right? So I know that Joel is here. Are you following, Joel? You understand?
Yes, sir. Yes,
All right. And that will mark the end of these presentations. So we have just done topic 5, 6. So we have 2 more presentations to go. 2 more. The last presentation, which is 9, 10, I believe you guys are going to end up being on Labor Day, which is the 20th. So you guys will get a bonus week. So that means I should grade you harder. Right, Joel?
No, sir. No, sir. No need.
But you get extra time.
No, but sir.
All right, guys. So that is it for class today. Sorry, we went a little overboard. A part of this whole process is for you to learn as well. It's not just to present the thing and then you're done. So if you present, and I think that there is more to add to what you present, we're going to have to use the time to do that. So that's kind of what was done today, why we went a little bit overboard. Anyway, I look forward to next week's presentation, which is going to be topic 7 and 8, differences between presentation drawings, construction drawings, and so forth, and mixed reality, MR and AR, and VR.
So question, sir. Is it that you're saying that with the suggestions that you made today, we can go back and make those changes to the presentation before uploading it?
No. I'm not marking the presentations when you upload it. I have already marked the presentation. However, however, in academia, I have to collect like evidence that you did the presentation, which is why you have to submit it. You understand? Please remember remember the tips that I've showed you guys today, right? Please think about when I mentioned about streamlining the presentation, and if you're using a video, and find ways to take out what is relevant for your presentation and use that. All right. Anyway, apologies for the overtime. That is it for class today. I will see you next week, Monday. All right, guys. Take care. Bye.